Thank you for participating in Morehead at Home Skywatching, hosted by Morehead Planetarium and Science Center. My name is Amy Sale, and I'm an educator at Morehead. We are a unit of the University of North Carolina at Chapel Hill, located on campus. We also work throughout the state through a number of outreach initiatives like our summer camp programs, mobile lab vans, and the annual North Carolina Science Festival. Our mission is to help people better understand science, technology, and health, and we do this through learning opportunities like this live virtual program. Thank you for joining us today for our session, How Dark is Your Sky? And I'll pass things off to Nick.
Thanks, Amy, and hello, everybody watching from home. Welcome to Morehead at Home Skywatching. I'm Nick Eakes. I'm an educator at the Morehead Planetarium and Science Center, and today we're going to take you on a trip through your nighttime sky. But you might be aware that not everybody's nighttime sky looks the same. So a couple of housekeeping things before we bring up our sky and start exploring. We want your questions. That's a big one. So if you have questions during the session, the best way to get them answered is to put them in the Q&A box that's kind of at the bottom of your Zoom screen here. And you can ask them, and at the end of the session, we'll take some time to try to answer as many questions as possible. Also, if you think of something maybe after the fact, this will be recorded and will be posted later on. So maybe you can get in touch that way as well. But the program that we're going to be using to explore our nighttime sky is called Stellarium, and you can find it at stellarium.org. No matter what kind of device you're on, maybe you could download it and try for yourself. But we're going to be using a PC version, a desktop PC version to be able to fly around our universe. So what I'm going to do for you is share my screen so that we can get a look at this nighttime sky. So here we go. All right, so you should be seeing not a nighttime sky, but a daytime sky. Just to orient you to Stellarium a little bit before we get going here, you might notice some big red letters on our horizon. Those are our cardinal directions. We are facing south in this view. You might notice west over here on our right, east on our left. So again, a daytime sky is where we start, but don't worry, we will move to the nighttime. And you might also notice the date and time down here just below south. That's going to help us keep track of where we are, because we will be kind of breaking some of the rules of space and time in order to move through our night. So with that being said, let's make it dark. We're going to try to analyze just how dark our sky is. And to do that, I'm going to move time forward. One of the hotkeys that you can use in Stellarium to do this is the letter L, as in lion. It's an appropriate letter because we'll be talking about Leo the lion a little bit today. But if you use L to move forward, you notice that my clock speeds up. A couple of objects appear to be moving through the sky. It might be a little funny that you see a black dot next to the sun there. Well, that is the outline of our moon. We're not going to be able to see it today because, as you can tell, it's almost in the same direction as the sun. So we call that phase of the moon a new moon. So it's going to be tricky to see the moon today, but we have plenty to see in our nighttime sky. So watch as the sun sets and we start to get a look at what else is out there. Okay, so I've paused us here a little after 9 p.m. I know 9 p.m. can be bedtime for some of us that are watching, but that's okay because the sky changes throughout the year. So if your bedtime doesn't give you a good view, maybe later in the year, it will. So one thing I wanted to point out before we get into discussing light pollution and how dark your sky is how to find the brightest star in the sky. And some of you might have heard of this star before. It's called Sirius, or the dog star. And my favorite way to find Sirius, or the dog star, is to use a constellation called Orion. Orion in the stories is supposed to look like a hunter, a great hunter in the sky. You might know Orion by a famous pattern within the constellation called the Belt of Orion. If you imagine a belt of 3 stars in a row, maybe you can look at our stellarium sky and see a small line of stars. I'll give you a hint. It's in the southwest, between west and southwest on our screen. So you might still see these big red letters in Orion right now. It's pretty low on the horizon. So I'm going to click on one of the stars of Orion. How about its shoulder? The star is called Betelgeuse. And I'll show you an outline of the constellation itself. Yeah, maybe if you use your imagination, you can tell that he has a belt of 3 stars in a row right here, shoulders, knees, big shield or a bow and arrow or a club up above his head. There are many stories that give Orion all sorts of different types of equipment. As you see, when we bring up our picture here in Stellarium, it looks like he's carrying some sort of animal skin. Well, we're using Orion to help us find the brightest star in the nighttime sky. And the best way to do that is to use a technique called star hopping. We talked all about star hopping last week, but this star hop is really easy. If you find that belt of 3 stars in a row, I'll even take down our lines there for you. If you find those 3 stars in a row, draw a line down to the next brightest star. And you can even tell on your screen, it's one of the brightest things up there. It might not be quite as bright as the bright planet Venus, but this is the brightest star in our nighttime sky. And it's part of a constellation. You saw its name pop up right here, called Canis Major, or the Big Dog. So I'm going to pass it over to Amy to talk a little bit about how we can tell differences in brightness between stars and other objects.
Thanks, Nick. So Nick's been talking about bright stars. There's a system for rating star brightness called magnitude. It was actually originally devised by an astronomer a long time ago, and he declared, okay, the brightest stars, we're going to call those magnitude 1, or first magnitude. The dimmest stars, the one you can barely see, we're going to call those 6th magnitude, or magnitude 6. So it kind of works in the opposite direction where you might expect. Lower numbers mean brighter appearing objects. Higher numbers mean dimmer objects. And it's a logarithmic scale. Every step in brightness, every step in number from magnitude 1 to magnitude 2, that's actually 2.5 times in brightness. And the scale's been refined and expanded in both directions. So if you can see on your screen, depending on the resolution on your screen, on the left top, Nick has clicked on the star Sirius and it brings up some information about it. So it says magnitude minus 1.45. So negative numbers are really bright appearing objects. So it turns out the brightest star in the night sky is best described with -1 or magnitude -1. As another example, Nick, could you click on Venus and let's see what magnitude pops up for that? -4.72. So Venus is quite a bit brighter than Sirius. And you can keep going. The full moon is -12 point something. The sun, which you do not want to spend any time looking directly at, is -26.7. So the more minus, the brighter it is. And then as you go to 4, 5, 6, and even 7, that would be very dim. And if we're talking 8 or 9 as a magnitude, well, you're going to need binoculars or a telescope to take a look at that. So you can think in terms of how good your sky is. So a good sky is dark. It means you can see lots of stars, including dim ones. And there's a concept called limiting magnitude. So for example, if your sky has a limiting magnitude of 1, that means you can only see stars that are first magnitude, 0 magnitude, and like -1 and anything brighter. That's not a very good sky. If you have a limiting magnitude of 6, that means you can see all those stars and then stars that are dimmer, that are 2nd, 3rd, 4th, 5th, 6th magnitude. That would be a really nice dark sky. So next what we want to do is actually show you some more constellations, including one in particular that is key for helping you determine how dark your sky is. And so Nick, if you don't mind taking it away next.
Sure. So the constellation that I mentioned earlier that we're going to try to find right now is called Leo the Lion. And Leo is going to be our helpful tool in determining how dark our sky is. But you might be wondering, where in the world is Leo in the sky? Well, the way that I like to find this constellation is by using something that's even more familiar to us. Many of us, whether we've heard stories or actually gone stargazing ourselves to find it, have found a shape called the Big Dipper. The Big Dipper is part of a larger constellation. It's a shape of 7 bright stars in the shape of a big soup spoon, or some folks think it looks like a bowl. It is high in our sky right now. High in the sky in Stellarium kind of means right here in the middle of the screen. The Big Dipper can be outlined by finding these 3 bright stars in the handle and 4 bright stars in the bowl. And you see that even in our light polluted sky, it looks kind of like a big soup spoon. So I'm going to click on one of these stars. It's one of our pointer stars called Doobie. In order to maybe give you a better look at the Big Dipper, I'm going to bring up a whole lot of shapes here. Didn't mean to bring them all up at the same time, but that happens. I'll try to bring up just the lines of Ursa Major, which is the larger constellation that the Big Dipper is a part of. You see that there are all these other connecting lines here. And the Big Dipper is just part of that larger constellation. So if you're curious, by the way, Ursa Major represents a big bear. So I've never seen a big bear with a long tail like that, but you can maybe use your imagination in the sky. We are going to use not the whole bear, but part of it, that Big Dipper, to help us find Leo the lion. So Leo is a cat. Cats generally do not like taking baths. I don't know about your cat at home if you have one, but my cat sure doesn't. So we're going to try to kind of coax Leo out of hiding by dripping some water on its head. And we have the perfect tool for dripping water in the Big Dipper. So I'll leave maybe just no lines or anything up right now. Hopefully you can still find our dipper here. But imagine that bowl of our Big Dipper is filled with water. It's an ancient constellation, an ancient asterism. So if you poke a hole in the bottom, it's surely going to leak. Imagine you're dripping water from the bottom of this Big Dipper onto the back of a large cat. So this can help us here. Fill the bowl up, drip water straight down. I know you're thinking that might not look quite like a cat. Well, that's okay. I can help you out a little bit here with another picture. You know, to me, this backwards question mark shape here kind of looks like a curly tail, and this triangle might actually look like the nose of a mouse, you know. So there's lots of ways to imagine the constellations, but those ancient astronomers, they saw a great lion in the sky. So using the Big Dipper, which should be visible even in a light polluted sky, you can find Leo, which is going to help us determine our darkness. So I'm going to send it back over to Amy to talk a little bit more.
All right, so Nick has got the star Regulus highlighted right now. It's often thought of as Leo the lion's heart. And if you're able to see on your screen, the magnitude is 1.35, so it's about a first magnitude star. That's a pretty bright star. So even if you live, you know, in an urban area with a lot of bad outdoor lighting, you'll probably still be able to see this star. This sky right now, by the way, represents more or less Chapel Hill's level of light pollution. So if we click around a little bit, maybe Nick, do you mind just sort of clicking around on a few stars? There's Algeba right there. So it's about a second magnitude star. And he's just going to click on a few more. So you can see more second magnitude stars in Leo. There's a third magnitude star. So if you can see that one, you know your sky is limiting magnitude 3 at least. And there's one that's about third magnitude, and so on. And there's probably some dimmer stars in that area of the sky as well, but we just can't see them right now. So what's going on? Why can't we see as many stars as we should? Well, it's because of something called light pollution. It has to do with the choices that we make with using lighting outside at night. Some of the lighting is very well designed. The lights are shielded. All the light goes down to the ground. That's usually what you're trying to see when you're out at night. We walk on the ground, we drive on the roads. We're not flying up 40 feet in the air. There's no real reason to light up the sky. Some lights, though, aren't so well designed, and they spray light everywhere, out in your eyes where it creates glare and ironically makes it harder to see, or up in the sky where it doesn't really do anyone any good. It actually is harmful to the environment. It's a waste of energy and pollution, and it also harms a lot of species. Turns out it's not so good for human health either to be exposed to artificial light at night. So Nick, could we go to a darker sky now and see what we're missing out on?
Absolutely. In the real world, you'd have to take a drive away from those city lights. But in Stellarium, it's kind of neat. You can actually use the sky and viewing options window right over here. I know it brings a big box up onto your screen, but there is a place here that says light pollution. or checkbox take from locations database. So you see that we have this box checked. So this is trying to give us an accurate look at the light pollution here in Chapel Hill, but we can tick that off for our purpose here today. On this scale, the light pollution is measured. Lower numbers are going to mean a darker sky, and higher numbers are more light pollution. So let's bump this down and get ourselves a really, truly dark sky and take a look at the difference.
And one thing we'd like you to think about right now is the darkest sky you have ever seen, whether it was at your house. Probably not. More than 99% of us in the continental US live in light polluted skies. Most people who think they have dark skies don't. They just have never seen a truly dark sky. But it's possible you've seen a dark enough sky that you've seen something called the Milky Way, a hazy band of light across the sky. And since at this time of the year, the Milky Way kind of lies sort of against the horizon, which makes it harder to see in the early evening hours. Nick, do you think we could stay up really late, maybe to about 5 a.m.?
Sure.
And this should pull the Milky Way in a different viewpoint. So we're going to experiment with something we haven't tried yet in these Morehead at Home sky watching sessions. I'd like to do a poll, and I'd like to ask you all, have you ever seen the Milky Way? And it's possible something just popped up. Oh, you get 2 questions. Can you see the Milky Way from your house? Yes or no? Have you ever seen the Milky Way? So go ahead and vote on that. We'll give you some time. And if you look around at your screen, so the Milky Way is not made of milk. It's actually starlight. It's the plane of our galaxy. Although all the stars you see in the night sky are part of the Milky Way galaxy. That hazy band we call the Milky Way is just where there's a lot more of them. And in future sessions, we can talk more about that if you all are interested.
And by the way, you might even be able to see the Milky Way here a little more central now that we've moved later into the evening.
Yeah, so again, this is a 5 a.m.-ish sky. So this is for those of you who like to stay up absurdly late or who get up really early. And the reason why we picked 5 rather than later is that this is kind of the last few moments before it would start to get light from the approaching sunrise. Notice that you have some real treats waiting for you. Oh, and I see the polling is gonna end in about 15 more seconds or so. So quickly submit your answers if you haven't already. You have some treats awaiting for you: Mars, Saturn, and Jupiter. And while we're waiting for people to submit their poll answers, Nick, do you mind clicking on Mars and then Saturn and Jupiter, and let's see how bright they are. Okay, so Mars is about magnitude 0, so that's pretty bright. That's going to be, you know, on the order of as bright as the brightest stars. And then what about Saturn? Saturn about the same, between 0 and first magnitude. And then what about Jupiter? Jupiter is really quite bright. Minus 2 point something. So that's brighter than Mars and Saturn, but not quite as bright as Venus. And Venus is incredibly bright. All right. So let's see. You all report that about half of you have seen the Milky Way. Okay, I hope the rest of you will put that on your life to-do list to go see it. And only 2 people can see the Milky Way from their houses. And that makes sense, because I'm guessing that a lot of you are watching this probably from the Triangle area of North Carolina. And it is quite light polluted in much of this area. Okay, so we wanted to point out, in particular, I wanted to tell you a little story about the Milky Way. And it involves 2 bright stars that are hanging out in that vicinity. And the 2 stars are part of a pattern of 3 stars that make a pretty good triangle. One of them is Vega, a very bright star, magnitude 0. And then we've got Altair, another very bright star, and then Deneb. which is also bright, although really it's more bright. It's actually intrinsically very, very bright, much brighter than those other two stars, by the way. It's just much farther away. So the story I wanted to share with you is from China. There are many different versions and variants of the story throughout Asia. And it's a Chinese story that relates to Vega and Altair and the Milky Way. And this is how it goes. A long time ago, there was a young man who lived in a village with his water buffalo, and they would work the fields together during the day, and then at night, the water buffalo would play in the water of the river, and the young man would lie on the riverbank and he would play his bamboo flute. And on one particular evening, the music of the flute traveled up and up and up to the realm of the heavens, the heavenly courts. And this was where the queen mother and the king father lived with their daughter, the weaver princess. Her job was to weave the heavenly silks, and she would drape them across the clouds to dry. Well, on this one evening, she heard the music of the flute, and she hopped down from cloud to cloud, down to the ground, where she met the young man, and they talked, and they sang together, and they fell madly in love, and they got married. And they were very happy together. But after a while, the water buffalo grew old and sick, and right before it died, it said to the young man, "When I'm gone, you must sew my hide into a cloak, because the cloak will perform a miracle for you." Well, soon he needed a miracle, because the queen mother was strolling by the heavenly loom one day and noticed she hadn't seen her daughter in a long time. So she sent the heavenly guards to find the weaver princess, and they found her on earth, and they put her back up in the sky, where she sat at the heavenly loom and watered the heavenly gardens with her tears, because she was separated from her husband. Well, the young man on every clear night would look up at the sky and try to get a glimpse of his wife. And then he remembered the buffalo cloak, and he put it on, and a miracle happened. He was lifted off the earth into the sky, and he was traveling higher and higher, and he could see the heavenly loom, and he could see the weaver princess rushing out to greet him with a smile on her face. But then he could see the queen mother behind her, and the queen mother took a silver pin out of her hair and drew a silver river across the sky. And then she took the young man and turned him into a star, Altair, and then turned her own daughter, the weaver princess, into a star, Vega, separated on either side of the silver river. But then the king father took pity on the couple, and he declared that once a year, on the 7th day of the 7th month, the magpies of the heavens would form a bridge across the sky, and for that one day only, the weaver princess could cross on the bridge and cross the silver river to hang out with her young man. And on that day, I've been told it's Chinese Valentine's Day. There is to be a feast to celebrate the couple. And if there's a rainbow in the sky during the day, it's because the weaver princess, in her haste to get to her young man, she's strewn her colorful silks across the sky. And that night, if it rains, it's the weaver princess sobbing, because she has to go back to the other side of the silver river for a whole another year. And just as a science epilogue to this story, Vega does not jog across the Milky Way at any time of the year. The stars do move, but they're so far away that from our point of view, they don't move really relative to one another over short periods of time. And a human lifetime is a short period of time, astronomically speaking. Many human lifetimes is a short period of time, astronomically speaking. So the people who first told this story, and it's at least a couple thousand years old, they saw the same patterns, the same star patterns that you can see, maybe not tonight, it's going to be cloudy probably, but on the next clear night. So we are connected to the people who came before us by the stories we tell about the sky. The sky is part of nature, it's part of our natural heritage, and it's part of our cultural heritage. Okay, and Nick, with that, I think we're gonna roll, we're gonna complete our all-nighter.
Oh yeah, this is the smoothest all-nighter you've ever had. You notice
Yes.
the glow of the sun is starting to make it a little tougher to see some of those things in the sky. The planets are still labeled here, but as the sun rises, you're going to lose your view of those planets in the early morning too.
The sun is nature's ultimate light polluter. When it's up, you don't see much else, except maybe the moon, but the moon is a very thin waxing crescent right now, so don't count on seeing it for another day, another night or so. And then I wanted to show you all, we pointed out how to find Leo the lion earlier, and I want to share my screen with you all and show you how you can contribute to a worldwide citizen science project to measure the darkness of your sky using LEO. So I've showing you the website Globe at Night. It's globeatnight.org. And it's a citizen science campaign. And if you click on campaign dates and constellations for 2020, it will take you to the list of all the dates that you can collect data. You'll see that April 23rd is the end of a campaign. So unfortunately, last I checked, at least for those of you watching from North Carolina, it does look like it's going to be cloudy over pretty much the entire state tonight. But you'll see below that, May 14th through 23rd, you can use LEO again to collect data. And the issue is it needs to be near new moon so that the moon is not lighting up the sky. And then what you do is you go out after dark, at least an hour after sunset, wait at least 10 minutes for your eyes to adjust. And then if you go to the globeatnight.org/web app, notice that it might ask you if it can access your location. I discovered that when I allowed location access, it pretty much pinpointed my house. So you feel free to do that on your own. And then you put in the date and time that you observe. You can also type in and do a search for the location that you're looking from. It works pretty well. And it will ask you to make comments about your location. And then this is the key part, step 3 here, how dark was the sky that night? So try to find Leo the lion by using the Big Dipper, and then pick the chart that best matches what you see. So if you couldn't see Leo at all, then you might have a sky that is the limiting magnitude is basically 0. That would be a very bad sky. Magnitude 1 is not so much better. You start to pick up Regulus and then a star in the tail of Leo if you have a limiting magnitude 2, and then so on. You start picking up more stars in Leo as the sky gets darker and darker. See if you can pick out Leo the lion as we keep going. Then you indicate the sky conditions that night, and then you submit your data. And then later you will be able to find your data included on a map where people have submitted data points around the world. So you can contribute to a light pollution awareness campaign on Globe at Night. So that's globeatnight.org. And so I hope you all are thinking about questions that you have. We have a couple of minutes for questions. Remember, at the bottom of your screen is a Q&A button, and you can type in questions that you have.
Well, I see a couple of good ones here. Here's one. Mary asks, what are some ways that we can stop light pollution?
Yeah, so, well, you can work on your immediate environment. You can think about your own home and whether you have any exterior lights that, that you don't need, that maybe you're using that you don't actually need. You can think about putting things on timers so that you're using the light only when you want it. Motion sensors, so it comes on only when you need it. You can also think about an appropriate level of brightness. Sometimes you don't need as bright a light as you might think to light the ground, and you definitely want to shield it. So the light is going down to the ground, not out in your eyes, which makes it harder to see, or up in the sky. You can also talk to your neighbors, and of course you can also talk to your town and find out what their policies are. Many towns have dark sky policies. If you've ever been to Flagstaff, Arizona, or if you've ever flown into Tucson, Arizona, you might have noticed that you see less light in the sky than you might otherwise expect for towns of those size, because they have observatories that need to be able to look at the sky. So they're very careful with how they use light.
Great.
Oh, there's a great question. Nick, what were the white dots moving across the night sky?
Yeah, that's a really good question, because you notice maybe even as it got darker in our sky, you saw more of them. Most of those are artificial satellites. So things that human beings have launched up into space that serve all sorts of purposes. So they could be helping us with telecommunications or mapping or doing scientific studies of the Earth. All sorts of things, but you can see satellites from here on the Earth. One of the most famous ones that we see often in our sky is the International Space Station, also known as the ISS. So the ISS orbits around the Earth about every 90 minutes, but that doesn't mean you're going to see it every 90 minutes from right at your house. I would definitely encourage everybody to maybe try to find the ISS on their own. There's a really easy way to do it by using a resource called spotthestation.nasa.gov, and I'll put that in the chat for you guys. So you'll have a link to it. And that allows you to put in your location, and then it'll tell you when the space station is going to pass overhead. So I don't think one of those that we saw in our sky tonight was the ISS. But something I like to do is when we do see the ISS pass overhead, you can wave because there are human beings up there on that spacecraft floating around and helping to learn more about science and our Earth. So yeah, most of those things that you saw kind of zoom across the screen were very likely satellites. Now, in stellarium, sometimes you can also see meteors, which are what some folks call shooting stars. We have it set so that occasionally you might see one of those because in a real dark sky, even if you're outside of a meteor shower time, you might be able to see a meteor as well. So those are probably the two things that you could have seen floating across the sky.
Okay, and I do see we're about out of time. Just really quickly tackle a couple of questions. We've got a question about, can you see Saturn, Jupiter, and Mars before 5 a.m.? Yes, they do rise before then. They'll be lower in the sky though. And then Hannah has a couple of questions about star brightness. Let me just tackle one of them. Does the brightness of stars change? Yes, some stars do vary in brightness and you can observe it. Sometimes with just your eyes. Betelgeuse in particular went through a period when that was a star in the shoulder of Orion. It dimmed and it was noticeable, and then it has started to brighten again. So Nick, I think we're out of time. We wanted to make a plug. Join us next Tuesday, 10 a.m. Eastern. We're going to take a whirlwind vacation through the solar system. So we hope you can see us then.
See you next time, everybody.
Thank you for joining us.